All right, here we go. Now, if you remember from yesterday, we have two types of equations that we're going to write for the equation for an ellipse. All right, but I told you guys, is the numerator ever going to be different? No, I always am going to write x minus h squared plus y minus k squared. So Layla and Natalia, this should seem familiar from circles, right? That's no different. But we have two options. Okay, I'm going to try to explain what the two options are. Okay, if I put a squared underneath the x and b squared underneath the y, do you remember what type of ellipse this would be? If I put the a squared underneath the x, it'd be horizontal. So you're going to see, Layla and Natalia, that a squared is always the bigger number. So whichever the bigger number is underneath, that helps you determine what type of ellipse it is. So in this case, if I go over here and put b squared underneath x and a squared underneath y, this is what we call a vertical ellipse. So I'll just kind of do a quick little sketch. So like this would be a vertical ellipse, and this is a horizontal ellipse. Yes, exactly. So this understanding, they should, in theory, know this from yesterday. Okay? So no. So basically when you do these, you're writing one of them, but you do Luke based on which one you decide. If it's horizontal or vertical, that changes where you put the a squared. So remember, the key thing is, whichever one it is, horizontal or vertical, that'll tell you where to put the bigger number. Okay, so let's do the first one. Natalia and Layla told them they should always sketch. It's only going to be easier if they sketch what it looks like. So let's sketch this one. Okay, where is the center? -1, -2. And actually, when you get to this link in Delta Math, they actually give you like a blank grid where you can actually sketch this. All right, so it can help you on the actual link do it. All right, so there's the center, -1, -2. It says there's a vertex at 3, -2. So 3, -2 is I go to the right 3, and I'm going down 2. So 3, -2. So the moment I do that, if this is a vertex, did you see what direction I moved from the center to get to that vertex? I moved horizontally. So if the vertex point is horizontally from the center, what type of ellipse is this? Horizontal. So Layla and Natalia, wherever the vertices are, if the vertices are left and right, it's horizontal. If the vertices are up and down, then it's going to be vertical. Okay? Now, the vice versa of that is the co-vertices go the other direction. So you'll see a co-vertex point is -1, -4, which is going to be down here. Okay? So that's a co-vertex point. So now what I taught them, and I know it's kind of small here, so I'll do my best. This distance from the center to a vertex point is A. The distance from the center to a vertex point is A. So let me write down the center, which was -1, -2. And guys, I think you can just count this, okay? If I'm counting from -1, -2 to 3, -2, how far do I have to count to get to this vertex? So -1 to +3. How far away is -1 to +3? It's 4 units. You guys see that? Because you got to do 1 to get to 0, and then you have 1, 2, 3 to get to that 3. You can also subtract, right? What is 3 minus -1? That's really 3 plus 1, which is 4. I think it'll be easier to count on the link, all right, because you can actually plot it. Okay, so A is 4. Now, the other distance from the center to a co-vertex is letter B. The distance from the center to a co-vertex is always letter B. So in this case, right, I'm counting from, this is -2 to get to -4. So how far away is -2 to get to -4? It's just 2 units, right? So B is 2. And if you know the center and you know A and B, you have everything you need to write the answer. Yes, go ahead. So distance is going to be always positive. All right. Even if you did say it was -2, it really won't matter at the end because you're going to square it, right? But I always tell students write A and B as always positives. So now I'm going to choose. You said it was horizontal, so I'm going to write this equation with everything I have. Okay, ready? All right. So think opposite for the center. So I see -1. So what's the opposite of -1? Positive. So I'm writing x plus 1 squared. This is a horizontal ellipse. So the denominator here with x has to have the bigger one. So which one is bigger, 4 or 2? 4. And don't forget to square it. What's 4 squared? 16. Okay. Plus, that's always going to be addition in the middle. Okay. What's the opposite of -2? Positive 2. Put the other one there. So what's 2 squared? Is 4. And that equals 1. That is the answer. And just for funsies, I made a horizontal ellipse around it. See what it did? No, Hector, not even chuckle? That's fine. No worries. Great. It's going to get harder. Yes, Luke. Center is H and K. So I put these into H and K. Right now, yeah. In a moment. Because I'm about to introduce something called the focus points or the foci. So like this right here is the ellipse we just drew. And we're about to talk about, there's 2 points, one right here and one right here that are like almost to the vertices that are called foci or focus points. They're a special case and they are a lot harder. And here we go, number 2. There's some foci. Okay, here we go. Let's sketch it. All right, so sketch your foci. 2, 11. So 2, 11. Oop, not -11, sorry. And then 2, -13. All right. Now, what you need to know about foci is the foci are always on the same line as the vertices. So even though these are not the vertices, do you see how I'm moving up and down for the foci? So if I'm moving up and down for the foci, that means I'm also moving up and down for the vertices. So what type of ellipse is this if I'm moving up and down for the vertices? Vertical. All right, so up and down for this one means it's a vertical ellipse. Now it tells us that the length of the major axis, this is the longer axis, is going to be 30. So what you need to know is that the major axis, and they did see this yesterday, is always equal to 2 times A. The major axis is always 2 times A. I'll write this down even though we don't need it for this problem. The minor axis, so the smaller one, is always 2 times B. Okay? So in this case, I'm going to write 2A equals 30, right? Because the length of the major axis is 30. So then what is A? What is A if 2 times A is 30? It's 15? You're just sitting. It's 15. Okay, so if they tell you the length of the major axis, they're essentially giving you A. You got to cut it in half, and that's A. If they give you the minor axis, they're trying to give you B. Cut that in half, that's B. Everyone all right? Okay, so if you wanted to, right, for a moment here, if we look, there should be a point right here that's in the center of these foci. So if you look, I'm going to put 2. How did I know it was 2? Because on the same line. What up, Luke? Guys, good job. So now I need to figure out what y value is in between 11 and -13. So this is where if you wanted to, Luke, like you were doing earlier, you could subtract. All right. So if I did -13 minus 11, what is -13 minus 11? -24. Okay, Luke. All right. So this distance here, try to show you, this distance all the way here is 24. So what is half of 24? It's 12, right? So what I'm trying to tell you is in terms of my letter C, I'm going to say that C is equal to 12. All right, and if I count, you can count from this one or from this one to get to this point. That'll give you the y value that's the center. So which one do you want to count from? The one on top or the one on bottom? Top? Okay, so if I count from here, if I count down 12 units, Notice what happens when I count down 11 units. It hits here, and it's going to go to the negative. How many more do I need to count to get to that last one? One more, right? Because this is 11, and then one more would be 12. So do you know what this y value is? -1. Nice job, guys. Well done. That's the center. So we just found the center. The center is 2, -1. Okay? Now, I've written down a couple of things. I wrote down A. I wrote down C. This is the hard part here. And what I told them yesterday, they have to memorize this. They need to know that C squared is equal to A squared minus B squared. They need to memorize that. Okay? That's the relationship between those lengths of those axes. Okay? So you just got to memorize that. I'm not expecting them to know it yet, but for the test in a couple weeks, got to memorize it. Okay? So I'm going to plug in 12 squared equals 15 squared minus B squared. See where I got all those? Okay? So 12 squared is 144. Does anyone know 15 squared? No, close. Too high. 225. Nice, Manny. So Donovan said 2? Thanks, Donovan. Now, if I move that over with subtraction, I get the opposite of B squared equals, what's 144 minus 225? -81. Do you see how they're both negatives there? So I can take those away to write B squared equals 81. So what is B? Nice, Natalia. Good. Okay, so remember, at this point, all I need to know in order to write this equation is, do I know A? Do I know B? Do I know the center? And do I know the type of ellipse? Then I'm ready to write the answer. Okay, here we go. See if you can follow along. So hopefully you saw I thought opposite for the center. Okay, what type of ellipse? It's vertical. So my A squared, which is 225, is going to go underneath the Y. Go ahead, Luke. Which one? No, it's supposed to be Y plus 1 because the center is -1. You can. And then my A squared, my B squared, which is 9. Or B is 9, B squared is 81. So this is the answer. So I think those are the hardest ones where they ask you to deal with the foci. Those are hard. They're tough. It is a lot, right? And especially you have to memorize this and do feels like Pythagorean theorem because it's from that. We have two more, and then I'm done, okay? 2 more. Flip it over when you're ready. 2 more. I try my best to show you guys all the different variations. Okay. Here's the foci again. All right, so foci at 18, -4. So that's 18, -4, and -6, -4. Now notice, how do those foci line up? When you look at them, which direction am I moving to do the foci? Horizontally, yeah, left and right. So what type of ellipse is this? Horizontal, right? Remember, the foci are on the same major axis as the vertices. So if the foci are going horizontally, so are the vertices. Always. Okay, for ellipses. And then let's plot the vertices. Should not surprise you that this is going to be 6, 1. I'm sorry, co-vertices. My bad, right there. Co-vertices. 6, 1, and 6, -9. So it kind of looks like this. Notice how I'm not going through the foci. Do you guys see that? Do you guys see how I drew it not through the foci? You don't draw through the foci. The vertices are a little bit past the foci. So that's why. Okay? So right here is the center. I'm hoping you can figure out the center, at least one part of it, right? This one up here was 6, 1. This one down here was 6, -9. So what do I know for sure is going to be the x value of my center? Is going to be 6. Nice, Manny. Right? Because it has to be in line with the co-vertices. Okay? Now, if you look going left and right, you can figure out that if you look at the foci, what do you notice about the y value for the foci? See, that's -4. So what's going to be the y value for the center? -4. So that one I didn't have to do any work to figure out the center. Now, a little bit, but I didn't have to do any like math. Okay? So I'm going to write the center is 6, -4. Now I can actually find letter B right now. Right? I can find, let me use it back to my blue. I can find letter B right now. The distance from the center to one of my co-vertices. So which way do you want? I wrote up, but you can also go down. I don't care. What's the distance from -4 to +1 or -4 to -9? Nice. Well done. So B is 5. Nice. Well done, Jasmine. B is 5. Now, this one from the center to a focus point is C. So what is the distance from 6 to 18 or from 6 to -6? It's the same thing. What's the distance from 6 to -6 or from 6 to 18? 12. What up, Donovan? Well done. So C is 12. All right, so I have to do that same formula that I did on the last one. C squared equals A squared minus B squared. So that's going to be 144 equals A squared minus 25. Remember, please, please, please let me know if you're confused by any numbers that I write. I just squared them in my head, right? I know what 12 squared is and what 5 squared is. Okay, so add 25. What's 144 plus 25? 169. Do you guys know the square root of 169? Nice, Mandy knows it. It's 13. Okay, so A is 13. So do I know the center? Do I know A? Do I know B? Do I know the type of ellipse? So let's write the answer. Okay, it's horizontal. So I'm going to put the bigger number, so A squared, underneath X. So 13 squared is 169, and 5 squared, which is B squared, is 25. Yes, Layla. Go ahead. Yes. We got one more, and then I'm done. Okay, one more. It's going to take some time, right? I'm not expecting you guys to be like super awesome at this yet. It's going to take time. And it's one of those things where it's kind of like what Minerva said, right? Maybe it was not Minerva. Somebody said, like, I gave up before I even tried, right? This is very much one of those links where there's going to be students that are not even going to try. Because it is like just jumping into it, you know it's going to be work. Okay? Like all the problems we've done have been plenty of work. Get your mind right before you do it, okay? Last one. Determine the equation of the ellipse with the center. So that's super nice because they give you the center. It's always helpful. So 2, 4. And it gives us actually the lengths of both axes. So the major axis is 12 and the minor axis is 10. Now they're giving you also another word, a couple of words to help you. If you look, it says horizontal major axis. So what does that tell me about this ellipse if the major axis is going left to right? If the major axis, which is the longer one, is going left and right, this is a horizontal ellipse. All right, so do I know the center? I now know it's horizontal. Do you remember what I write for the length of the major axis? I know it's 12. But do you remember what I wrote from question number 2? It's 2 times A equals the major axis. And what did I write for the minor axis? 2 times B is equal to the minor axis. So what is A? 6. And what is B? 5. So now do I know all 4 things? I do. I know the center. I know A and B. And I know the type of ellipse, right? Type. Here we go. So x minus 2 squared, y minus 4 squared, So did you say something to tell me about C? So you don't need to know C. What you'll notice in number 2 and number 3, I had to use that formula with C to find A or B. But if I know A or B, or both of them, I don't need to worry about C. I only use that foci stuff when it has the foci. So a lot of my students will be excited when they don't see anything about focus points. Okay, it's horizontal, so I'm going to put 36 here and 25 here. All right, guys, that is it. That's how I do these questions.